I'm sure many of you have seen this formula before, the e to the I theta equals cos theta plus I sine theta. And if you've done like a complex analysis course, you might have not seen a proof of this. It might have just been given to you as a definition. You might have seen other proofs of this involving Riemann sums. Today, I'm going to show my proof. Okay, so a simpler question would be to ask if we could find a number, a complex number, such that e to the z equals -1. Obviously, we cannot find a real number that does this because e to the z for any real z is a positive real number. But we know that we can find complex numbers such that z squared equals -1. In fact, we know what these complex numbers are. It's I and -I. So if we could find a complex number e to the a complex number z such that e to the z equals -1, you can figure out the exponential function for complex numbers from there. So let's just suppose that this number exists. Let's call it z naught, and e to the z naught equals -1. And in the last video, I showed that -1 to the x equals cos pi x plus I sine pi x, which is the cis function, cis pi x. And yes, this was heavily justified in the last video. I recommend you go check it out if you haven't already. So with these things in mind, let's define a function. So f at x equals -1 to the x. Well, -1 equals e to the z naught. So -1 to the x equals e to the z naught to the x, which is equal to e to the z naught x. And by transitivity, is equal to cis pi x. Now you might be wondering, well, if e to the e to the z naught, if z naught is a complex number, then does the rule apply for e to the z naught to the x equals e to the z naught x? Well, I guess we don't know, but since we're extending the definition of the exponential function to the complex numbers, we'd hope that the same rules would apply. Okay, now that we've got this out of the way, there's a clever trick to solving for z naught that that gives us one of the solutions. Can you figure it out what it is? If you've paused and pondered for a moment, you may have seen that if you take the derivative at 0 of this function, so f prime at 0 equals e to the z naught x prime evaluated at x equals 0, which is equal to z naught e to the z naught x at x equals 0. And since e to the z naught 0 is e to the 0, which is 1, this is all just z naught. Okay. Well, that's just doing the derivative at 0 at one of the functions. So we have a transitive formula for z naught. We'll take the derivative of the right side. So f prime at 0, cis pi x, which is 6 pi x prime, evaluated at x equals 0. This is equal to cos pi x plus I sine pi x, prime evaluated at x equals 0, which is negative pi sine pi x plus I pi cos pi x at x equals 0. And this is negative pi sine pi 0 plus I pi cos pi 0. Now sine pi 0 equals 0, and cos pi 0 equals 1. So this is I pi. So once again, by transitivity, z naught equals I pi, which means that e to the z naught equals e to the I pi x, which is equal to cis pi x. And just using a substitution of variables, let theta equals pi x, we get e to the I theta equals cos theta plus I sine theta. Proved. Thank you all so much for watching. Stay tuned for the next video. Cheers.